Welcome. Thank you for attending my talk titled Beyond Fortune 500 – Women in a Global Network of Directors. My name is Michael Gastner, and the research I'm going to present was conducted jointly with Anna Evtushenko. Anna was an undergraduate student at Yale and US College, and this research was part of her capstone project. Anna is now pursuing a PhD at Cornell University. The topic of this presentation is the role that women directors play in the interlock of company boards. We will look at the position of women in the professional network and the distribution of female directors by country, sector, and industry. In many countries, there is an intense political debate about how to increase the number of women on corporate boards. Pilita Clark summarized the situation in a 2019 opinion article in the Financial Times. Laws forcing companies to put women on the board were something you saw in places such as Norway or California. The idea of being a quota appointment made a lot of women uneasy, including me. But change at the top has been sluggish. No wonder women are growing impatient, especially when so many diversity advocates argue there is a sound business case for more female leaders. Appointments to corporate boards are often the result of professional networking. As Roseanne Horwarden wrote, membership on boards is a self-organizing structure whose form is the result of innumerable selection decisions that are driven by shoulder tapping or inviting peers to join other boards, and by connector directors with multiple seats cherry-picking the less risky and more prestigious board seats. Consequently, if we want to lead an informed debate about the current role of women on corporate boards, we must look at their positions in the network of directors. For our research project, we gathered data for approximately 320,000 directors sitting on the boards of approximately 36,000 companies traded on stock exchanges all over the world. From these data, we construct a network of interlocking directorates, which allows us to test several hypotheses in the previous literature about female board representation. In this talk, I focus on two hypotheses: the overboarding hypothesis and the token woman hypothesis. The overboarding hypothesis claims that female directors are recruited from a limited pool of women to multiple boards. Overboarding is the corporate governance term used for directors who sit on too many boards at the same time. The token woman hypothesis claims that women face an implicit quota, whereby a firm's leadership makes an effort to have a small number of women in top management, but makes less effort to have, or even resists having, larger numbers of women. In consequence, the presence of a woman on a top management team reduces the likelihood that another woman occupies a position on that team. Do these hypotheses stand up to quantitative scrutiny? We obtained data about companies and the directors from the Financial Times website for the year 2016. Each company was identified by a stock ticker code. A tab on the website listed the names of the company's directors. For most directors, the website included a short biography. If the biography started with the word Mr., we assumed that the director was male. If the first word in the biography was Mrs., we assumed that the director was female. Otherwise, we resorted to the Python package Sex Machine to infer the gender from the director's given name. The company's sector and industry were stated on the website. Also included in the company profile, but not shown here, was the address, from which we inferred the company's country. From these data, we can construct a bipartite network where the nodes are companies and directors. For every board seat, there is an edge between the company and the director. Because we are ultimately interested in the professional network of the directors, we performed a one-mode projection in which all nodes are directors, and there is an edge for every joint board membership. The one-mode projection contains 321,967 nodes and 2,809,623 edges. We identified 30,386 nodes as female directors, which amounts to 9.4% of all nodes. This percentage is only an estimate because we were unable to identify the gender of 29.7% of the nodes. When we form subgraphs that only contain nodes of one gender, we find that the male subgraph contains many more edges than the female subgraph. The diameter, average path length, and density of the male subgraph are smaller, but the number of components and the percentage of nodes in the largest component are approximately equal for both subgraphs. The network data allow us to investigate whether women have a stronger tendency to sit on multiple boards than men. If overboarding were more common among women, we would expect the percentage of female directors to be substantially lower than the percentage of female seats. However, we find that the percentages are almost the same, 9.4% versus 9.7%. We also find that the percentage of directors sitting on multiple boards hardly differs between women and men, 14.7% versus 14.8%. On the basis of these numbers, we conclude that overboarding is not substantially more prevalent among women than men. Differences between the genders are more pronounced when we split the data by sector. The largest proportion of female directors is in financials, consumer services, and telecommunications, where women have more than 11% of the board seats. At the opposite end, in technology and basic materials, less than 8% of seats are occupied by women. Our findings are consistent with a previous study by the Credit Suisse Research Institute. A more nuanced picture emerges when we subdivide each sector by industry. Here I show as an example the results for consumer goods. The proportion of female seats ranges from 11.2% in the tobacco industry to 5.7% for automobiles and parts. Even more striking are the differences between countries. The top-ranked country in our data is Ukraine, where women have 22.6% of the board seats. We have not found previous reports on female directors in Ukraine, so we cannot rule out that its top rank is owed to a relatively small sample size of only 19 Ukrainian companies. Most Scandinavian countries are also highly ranked, for example Sweden with 21.5% and Norway with 19.7%. Near the bottom of the ranking is Japan. Our estimate of 1.2% is even lower than previous estimates by Credit Suisse and Deloitte. Another measure for comparing female representation across countries is the proportion of companies with at least one woman on their boards. Worldwide, we find that 50.3% of companies have at least one female director. The country rankings are broadly comparable to the rankings for female seat proportion which I showed on the previous slide. 3 Scandinavian countries, Finland, Norway and Sweden, are in the top 4, and 3 Southeast Asian countries, Thailand, the Philippines and Singapore, are in the top 10. At the opposite end of the ranking are Oman, Japan, Pakistan and Qatar, where less than 15% of companies have at least one female board member. We can use these numbers to investigate the token woman hypothesis that claims that the presence of a woman on a board reduces the probability that another woman is recruited to the same board. We build a simple mathematical model for the null hypothesis that seats are assigned to women independently of the gender of the other directors. We treat the observed fraction of female seats in a country and the fraction of boards with S seats as input parameters, called P and Fs respectively. The probability that a company with S board members has at least one female board member is the expression inside the square brackets. Weighting this probability by the fraction of companies with S board members, we obtain an expression for the expected proportion of boards with at least one woman. If the token woman hypothesis is true, companies aim to recruit exactly one woman. Consequently, the token woman hypothesis posits that the observed proportion of boards with at least one woman is larger than predicted by the null model. Our data do not support this hypothesis. Worldwide, we find that the null model predicts a higher proportion, 0.604 versus 0.507. We also repeated the calculation for each country separately. Slovenia is the only case out of 54 countries where the null model predicts a too low fraction of single woman boards, but even there the predicted proportion is only lower by 0.13%. In all other countries, the null model leads to a higher proportion than the data. In the bar plot, we show the additionally predicted proportion as blue segments. In summary, the token woman hypothesis is not supported by data. Instead, our results suggest the opposite narrative. If one woman is recruited to a board, more women are likely to follow. This phenomenon is expected to leave an imprint on the network structure. By construction, every board is represented by a completely connected subgraph in the network of directors. The mean board size in our data is 11.02. The mean size of boards without women is 8.88, whereas the mean size of boards with at least one woman is 13.10. The fact that boards without women tend to be smaller than boards with female representation is not surprising. Even if seats are assigned according to our null model, that is independently to men and women, we expect single-gender boards to become less likely if there are more seats. A more meaningful comparison is between the observed mean board size and the expected mean board size in our null model. The effect size is small, 13.10 according to the data, 12.97 according to the null model. However, the difference is unlikely to be the result of randomness alone. The p-value is smaller than 10 to the minus 8. Therefore, we conclude that a seat is more likely to be occupied by a woman if that seat is on a larger board. Directors on larger boards tend to have more connections to other directors, so they also tend to be in larger components of the network. Consistent with our finding that larger boards are more likely to recruit women, we find that the proportion of women in the largest component is higher than the proportion of men, 79.4% versus 74.8%. The difference is significant. The p-value of a permutation test is below 10 to the minus 15. We conclude that women are a minority, but they are not marginalized by being confined to small components. Restricting the calculations to the largest component, we applied standard measures of node importance from social network theory. In terms of degree, eigenvector centrality, betweenness centrality, and clustering coefficient, female nodes are at least as important as male nodes. In summary, we analyzed a global network of directors on boards of companies traded on stock exchanges around the world. Only 13.4% of those directors for which we know the gender are women. There are significant differences in female representation by sector, industry, and country. While these results are consistent with previous findings, we did not find evidence for several hypotheses in the previous literature. We found no evidence that women tend to overboard more than men. We found no empirical support for the hypothesis that women tend to be recruited as tokens who block the access of other women to the same board. And we found no evidence that women are marginalized in the network. I hope you found this presentation interesting. We have made our data publicly available on Zenodo. Feel free to use our data for your own research. I shall be glad to answer your questions and support your research about the topic of gender representation on corporate boards. Thank you.